Okay, don't worry, we'll edit this introduction later. So it is a digital world. Afterwards, everything is perfect, you know what I mean? So
A live session is always a bit, makes you feel a bit stressed, like.
no, not to worry. I mean, the people who is involved, they are basically researchers from other projects. We have very interesting people that registered. Very well-known researchers that are working in this area, in the Atlantic and Arctic. They want to connect because they work on freshwater restoration as well. So basically, it'll be an open conversation, and then we'll moderate together. Asking questions. Is that okay for you?
Yes, of course. I will need help with the questions, and of course, yeah, I will. Anything from the audience is welcome to the extent that we can answer. I mean, at
Yes.
least the speakers that are present now.
Yeah. Please tell Anastasia, please, when you start, please tell the audience to write the questions in the Q&A box, not into the chat, so we can concentrate on these questions. Okay. We have two boxes here. Can you see? Chat and also Q&A. So, okay.
Q&A box. And how do you want to moderate it? Do you want to have Q&As after each DPS presents or at the end?
At the end is much better. Otherwise, you know what's going to happen? And then otherwise the last speaker won't have time to talk,
Yeah.
Okay. So I will open the session now. You wait for 1 or 2 minutes, okay? I will disappear in the background. I will manage the presentation.
Good.
Okay. And when we started the moderation, I will be back. Okay? So
2
have a
minutes,
nice
right? About 2
presentation.
minutes for people
Yes, yeah, to join. We'll have with this number, we have not many, 20, 25 people online, but then I will monitor on YouTube as well, okay?
Good. I'll wait then.
So we start now.
Mhm. Hello, everyone. Welcome to the weekly hour with Dalia today. Let's just wait for a couple of minutes for more people to join. And we will start slowly. Let's wait for a little longer. For those who can't see the chat, Zoje, who is our host today, is urging us to write down our name, affiliation, and current location just to see where you're watching the webinar from. Thank you for providing the link to the DALIA web pages, Jose. Okay. I cannot see how many people have joined online. So Zoja, if you think that it's the right moment to start with the webinar, you can share the presentation perhaps.
Yes, let's start. I mean, we have more than 60 people on YouTube.
Oh, that's so
It's time
nice.
to start.
Hi, everyone.
Yeah.
Richard from the Norwegian Institute of Water Research, Norway. Hi. This is DPS 8. That's a little forward in the presentation. We will have to take it from the top. It was a spoiler. Okay, that is great. Thank you very much. I think it's time to start. First of all, I would like to thank from the heart BlueMissionAA for inviting us to this webinar. It was a very, very nice opportunity and very warm one to let us share the DALIA progress and activities here. I'm Anastasia Peruli on behalf of the BioEast Hub of Czech Republic. And today we will be presenting DALIA. DALIA stands for Danube Lighthouse Innovation Action. And if we move on to the next slide. A few words about DALIA. DALIA is focused on the Danube River Basin, freshwater. It's an innovation action, and it's supporting the EU mission Restore Our Ocean and Waters by 2030, the Danube Lighthouse. And just to give a big picture of why the Danube is so important to us, I would like to quote our missions manager, Mr. Kęstutis Sodaskas, Deputy Director General of DG Mare. He was present in a high-level conference involving the BioEast initiative into the implementation of EU mission. This was organized in Prague last December 22. And he mentioned that the Danube is the biggest river in Europe, and therefore it's a symbol and it's designed to provide freshwater solutions that can be replicated elsewhere in the EU. This is the message that we want to give here, that everything that is happening on the Danube right now, it's the largest river. It can be an example for many, many other activities and rivers across Europe and further. To the next slide, please. So the project goals are, of course, to develop demonstrator pilot sites, which will provide prosperous user-centered solutions, meaning solutions that can be taken and replicated, and to review the current freshwater restoration assessment frameworks and relevant guidance and standards. Next slide, please. 22 partners are cooperating for this goal. From 9 different countries for the next 3 years, I think. If we can move on to the next slide, I can happily tell you that this month we're celebrating 1 year of DALIA. We have been operating already, and to share just a few achievements and brag a little bit, we have managed to establish a network of related initiatives, which you can find on the DALIA web pages. We have provided 4 videos regarding DALIA. We presented on the 19th World Lake Conference in Balaton in 2023. We produced the first DALIA newsletter and contributed to the EcoDALI newsletter. The EcoDALI newsletter is an initiative to join forces and share news from all the Danube-related projects, not just DALIA. So it's good to follow too if you wish. And we had the chance also to visit the Hungarian pilot site. Next slide, please. For the next year, this year, our plans are a bit ambitious. I mean, this March, we are launching the first version of our Knowledge Hub. Knowledge Hub will be an online platform to share useful materials, DALIA outputs, information from the demo results, data, and many, many more things. So stay tuned for March. There will be a first version. Maybe you can provide feedback. It's always welcome. And in April, we will launch our open call for applications, so stay tuned. More information will follow with guidelines and eligibility criteria and everything. Next slide, please. Another thing coming in March will be a clustering event for freshwater related projects. This will be organized in collaboration with the BioEast macro-regional thematic working group on freshwater-based bioeconomy. It will be in Brussels, 19th of March 2024. Book it in your calendars if you want to participate. We will be very happy to see you there. And the goal of this event is to show the importance of freshwater-related issues, strengthen the collaboration among projects, and involve policymakers in scaling up our activities. More information on the event will follow both on DALIA and on the BioEast initiative website. So we will share it soon once available. Next slide, please. So now I will shortly mention namely the DPSs in DALIA. We have in total 9 demo sites. 6 of them managed to be present here and talk about their activities. So the first one is in Hungary. It aims to revitalize the ecological system in Szigetköz region. I hope I'm pronouncing it correctly, but I think that Mate will give us more insight regarding this later. In the next slide, we have Neuburg and Ingolstadt, equally killing the pronunciation. Bernd will help me with this later. It's in Germany to reconnect the floodplain. Next, DPS 3, it's in the Czech Republic, located in the DJ subcatchment of the Danube River Basin. DPS 4, in Slovakia, the upper catchment of Vah River rehydration. More information will follow from Mikhail in this issue. Next, DPS 5, Begecka Jama, Sustainable Solutions for Ecosystem Monitoring and Restoration. Attila is responsible for filling us in regarding DPS 5. DPS 6, Romanian demo site for sturgeon vegetation bypass Iron Gains Land 2. DPS 7, Danube Delta in Romania regarding monitoring the system knowledge of sediment flows spilled in the Black Sea. Stefan will inform us about it. And DPS 8 in Bodrog River, Hungary, tackling plastic waste in the Bodrog floodplain. Miklos, thank you for being here today. He will inform us about the activities in DPS 8. DPS 9, final one. Again in Romania, in A-AAGORA water basin, to achieve a good ecological status. This is our goal. So we will try in the demo sites not to dive into technical details today, but mostly on the local issues, the measures that are being taken at the moment and their value, how they can be provided like solutions for different regions, and see perhaps, I hope that by the end of this webinar, you will see some prospects in replicating maybe in your region, or it will inspire you to participate in the open call maybe, but to see the value that can be replicated in other regions. And now I will slowly hand over to my partner, Mate, for DPS 1.
Yes, thank you.
The stage is yours. Thank you for being here today.
Okay, thank you. Thank you so much for having me. I'm Mate from Hungary, from Széchenyi University. I hope you can hear me. If you can just give a feedback.
I can hear you. It would be nice to see feedback from the chat as well.
That's great. So next slide, please. Okay, so Szigetköz, the first pilot site in DALIA project, is located in northwestern Hungary. As you can see it on these maps, it is a large island created by the Danube. And what's important is that, as you can see on the top right map, the Danube comes through the Alps and the Carpathian Mountains in Bratislava region. And after that, the sediments in the river are deposited. historically. And that's how Szigetköz was created. It consists of many, many small islands, many Danube branches. It's a floodplain area, and the Szigetköz, the name, this large island comes from two Danube branches, the main branch, which is today the border between Slovakia and Hungary, and the southernmost branch, which is the Mosoni Danube, that also flows through Győr, which is the location of my university. So next slide, please. You can see from 1785 a historical map and a picture that is not as old, of course, but shows how Szigetköz looked like in these old times. But after that, and next slide, please. From that, in 1992, we came to a very different scenario, a very different site, when active floodplain branches and historical floodplain branches went completely dry. But how this happened? Next slide, please. You can see it had many steps, many water management interventions in the Szigetköz area. One and very important was the creation of a main riverbed for the purposes of navigation, and also creating flood protection levees and thus reducing the size of the floodplain and dividing the floodplain to historical and active floodplains next to the Danube. Next slide, please. And after this, because there were still problems with navigation, and there was a problem with riverbed incision because of upstream hydropower plants. A solution was proposed to build a hydropower plant which used a diversion channel. And you can see on this satellite image the construction phase of this diversion channel. And if I can ask for the next slide, please, you can see when the water, the Danube, was diverted towards the hydropower plant, in the main channel, water flows were reduced by 80%, and this has resulted in the drop of water levels, and it affected the historical floodplain and the active floodplain as well, and creating those pictures with empty riverbeds that I have shown previously. So that was the case in 1993, and of course this resulted in the next slide. We can see in divided water bodies, both in the Slovakian side and in the Hungarian side, in the old Danube River, in the floodplain channels, protected floodplain or historic floodplain, as we call it, and of course the supply channel on the left towards the Gabčíkovo hydropower plant. So it was a very divided system, and replenishment was needed very much. Next slide, please. So here we see that this replenishment activity actually lasted for 30 years, and still there are some parts which are not replenished. Water, I mean, floodplain replenishment mainly meant in this case replenishing water levels to a certain time that was in the 1950s. This was the era when, according to all the stakeholders that participated in the restoration activity, this was the reference period that they could agree that they want to have water levels from the 1950s recreated both in the active and historical floodplain and in the Mosonai Danube as well. And you can see here that many hundreds of kilometers of river branches have been restored in terms of water levels. And because there was a lack of water flow, because water flow was diverted towards the hydropower plant, this could only have been achieved with water management works. And we will see some examples for that in the next slide. So the main characteristics of this restoration, which actually give the replicability potential, was that this was a diversion hydropower channel setup, and both the active and historical floodplains were restored. It was decided to be a dynamically controlled system, so it is not it doesn't mean that the water levels have been recovered, that it is a static system and it is just being filled up with water and then left there for good. But it's controlled dynamically from day to day, depending on the natural flows of the Danube River. It's very important. And of course, the longitudinal connectivity of the river and the lateral connectivity was somehow tried to be restored as well. This was done through many fish passes, and the stakeholder involvement was a huge part of this restoration activity, because many different and in many cases conflicting interests from different water-related sectors were involved, and these needed to be reconciled. So in the next slide, you will just see some pictures after the replenishment, the water replenishment in the active and historical floodplains. The situation there, many water uses, irrigation, tourism, and also forestry, agriculture. They all benefited from restoring water levels, which also affected groundwater levels in the region as well. Next slide, please. This is about the dynamic control that I was mentioning, and water allocation between floodplain branches. It is detailed. It is given in much more detail in our documentation, and it will be included in the knowledge transfer. Next slide, please. There is also artificial flooding included in this dynamic control. Next slide, please. There are many, as I mentioned, fish passages between those river branches, and each of them needed to have a unique design. And in the next slide, we can also see some different setups for these fish passes. And in the next slide, you can just see one picture of stakeholder involvement. There is a Szigetköz operating committee, which was formed during the restoration activities, and all water-related sectors are present here. It continues to have annual meetings, and it is supervising and also advising the operation of the system, and it is a place to resolve the conflicts between the water users as well. And the next slide is just a summary about what our actions involve in the Szigetköz area. It is first quantifying the benefits together with the stakeholders to actually validate the effects and the positive outcomes of this restoration activity further. So this is a research activity that we are currently doing, and it will help replication sites to know what is or what can be expected from replication. We will create, in terms of knowledge transfer, guidelines and manuals, and offer a consultation possibility. And in terms of educational materials, we will, both for local and wider public, create programs, training, capacity building, to actually help to get the message to everyone. And in the next slide, I have just summed up what could be replicated, what is the replication potential. We think, because of the time and budget limit of replication, we think that the design solutions could be replicated, but actually, if there is a system with the diversion canal hydropower, and I will give some examples what we have thought of in other rivers or other locations, the operation of our system could be adapted or transferred to these locations. And this is the dynamic control, this is the artificial flooding, and also the policy and decision making. What we do here in the Szigetköz region, the Szigetköz Operating Committee has some good practices as well. And in the last slide, you can see the locations that we have identified, which look similar, could have similar problems, but maybe you watching know about other sites with this diversion canal hydropower setups, and we are very happy to consult about potential replication. So thank you very much for your attention. I hope my last slide is about thanking you. Okay, and
thank you very much, Mate. Thank you very much for giving this insight to us. Now I think it's time for our colleague Bernd Sivka to share his own screen and share his presentation with us. Perfect.
Okay, can you hear me?
Yes.
Yes, that's nice. Thank you for letting me present our demo site here. My name is Bernd Sivka. I'm coming from the Floodplain Institute in Neuburg on the Danube, which is a research institute of the Catholic University of Eichstätt-Ingolstadt. It's a difficult name, Anastasia. So I did some last-minute changes, and that's why I'm presenting from my screen. Sorry for the organizers for this trouble, but I hope it will work. Yes.
Manage, no worries.
So can you see my screen?
Yes, I can see your screen with some disruptions, but I can.
You have to swap. Sorry, you go up on the ribbon on the top left side, and please swap, because you are watching, I mean, the other is if you click down. No, the other one, yes, in the middle, just click in the middle. There's a small, I mean.
Okay.
Let me start it again.
Yeah.
So the presentation is where? So presentation starts. I will share the screen.
Mm-hmm.
And this should work now. And in the middle, what do you mean? I can...
Now it's perfect. Now it's perfect.
Yeah.
Perfect.
It's
Okay,
good.
that's
good.
nice. So thanks a lot for letting me present our demo site, which is devoted to the reconnected floodplain of the Upper Danube in Germany. And I'd like to show you the implementation measures we we did. So the reason for the restorations were the separation of the river and the floodplain due to a hydropower plant. So not only Matthias's power plant, we also have our power plant. Here you can see it in this aerial photograph over here, and you can see also the research area, which is in this case south of the Danube, on the right side of the Danube. It's a huge floodplain forest of about 1,200 hectares, and this is the pilot site. It's the research site. We have an inventory of disturbance. There's a change of the entire hydrological dynamics, change in surface water dynamics, and also a change in groundwater dynamics. There's a drying up of the floodplain, for sure. No water is on the floodplain because of this inundation area of the hydropower plant. We have no typical morphological features. As you know, oxbows, river banks, erosion, and so on. Nothing was there after 40 years after the construction of this hydropower plant in 1970. And there's a danger of the extinction of specific species, specific floodplain species. And for sure, and this was a possibility to set up this project. There was no possibility for migrating fish to pass because of the EU directions. Let me show this map of our measures, and I have to say that I will start after my presentation a video which I recorded during another EU project which was finished in 2019. It was called Danube Floodplain, and during this project we had a summer school, and I showed this video which you will see afterwards during the summer school, and it's very, very good to understand what I'm presenting now here, what we do have installed. We are the Water Management Authority of Ingolstadt. We have a sluice gate for ecological flooding, so you can see it on the left side of this map. Do you see my cursor here? I hope so. This is sluice for ecological flooding, and we can let out about up to 30 cubic meters per second from the Danube, and this is valid for 2 to 5 days, and we have it 2 to 3 years. We have 1 year without, also already without an ecological flooding, and we have also 5 ecological floodings per year. And then the main measure is the new floodplain river. It's here, it goes along on the floodplain. It's about 8 kilometers of length, and we have a sluice where 1 to 5 cubic meters per second is endowed from the Danube water, and so the river is flowing permanently. That's absolutely important because this floodplain river, we have 3 return flows here in this floodplain river, and it's a possibility for migrating fish to enter up this hydropower station here in Bergheim. And the third measure is a so-called plank wire or with stop locks, and there's a sluice for groundwater drawdown during low flow periods of the Danube. We had these low flow periods a couple of times during the last years, but normally in the late summer, maybe September around, the Danube is below 150 cubic meters a second, and then we can stop. We can install the stop locks here. You can see it in the video later on. And then this area here over is drained, and this brings up dynamics to the groundwater. Groundwater goes down, and with the next flooding, groundwater goes up, and that's the most important thing we have. So what is going on? We have scientific and biotic and abiotic monitoring of the effects of restoration. We did this since 2009 with with a basic set of parameters, an expanded set of parameters that depends on the funding and depends on the money we got. We have an assessment of ecosystem services over there, and we have for sure consultations with our stakeholders from the county of Neuburg-Schrobenhausen, the Nature Conservation Authority, the Water Management Authority, and also with NGOs and of course with the landowner. So we are in yes, permanent contact with these stakeholders. What are we doing also to this? If you have not too much money and you are belonging to the university, the idea came up to make research on related topics by BSc and MSc thesis. This we have always maybe 2 or 3 theses running per year. And we are serving as a knowledge platform for floodplain ecology and restoration locally, but also regionally and nationwide. So we were asked, what is our opinion to do this or that? And we have support in the development of measures for environmental education. So we made brochures and so on in this case. And to come that what also Mate mentioned, what are the replication possibilities? And these possibilities are very close to them, what Mate mentions. All measures can be replicated in a dammed up river environments or in environments where it is necessary to reconnect the floodplain to the river. As Mate said, there is a provision that there are respective financial resources and that there's an official approval. This could last years, at least in Germany, it will last for many years. But the local measures can be adapted to a smaller scale. That's important. We have the experience of these large scale measures, and we can adapt it to a shorter scale. And the experience gained from our TPS can be used for other rivers and floodplains for smaller ones. This is important. The experiences in monitoring design of abiotic and biotic processes can be replicated to areas under pressure. It's important to know. And for sure, we have experiences and can replicate them in the case of environmental education measures and features, such as information boards, brochures, films, and so on, to show the public the value of nature. It's the most important to inform the public what is going on. So this was my presentation for this, and now I will show you with aerial images. We have drone flights over there, how the measures are working. It's divided up in these 3 parts: the ecological flooding, the floodplain river, and the groundwater drawdown. And I hope you can see and hear me again. So I'm not too lazy, but I did this couple of years ago, so it's easy to show the video. Let me try. It is this optimizing for video. And do you see a white screen? Sorry?
Yes, we do. Yes, we do.
Then where I will start. Everything okay?
Let's talk about the sluice gate for ecological floodings. This gate is constructed to bring more water to the floodplain and to mimic the natural annual floods that are not reaching the floodplain anymore due to the construction of the hydropower station. The gate can let out 25 cubic meters per second at maximum, and the water is taken directly from the Danube discharge. It will be opened only when the Danube discharge is higher than 600
cubic meters per second, and this happens statistically
2 to 3 times per year. Up to now, there was the gate
only for
2 to 3 days
on average per event. Longer times are possible and desirable. With an open
sluice gate, about
2.5 million cubic meters per day of water flow in the floodplain. Most of this amount
goes through and
returns to the Danube, but a reasonable share seeps through the gravel bases to the groundwater.
So recharge of the groundwater is done. The water rushes at high velocity, and so there are fluvial morphological effects like erosion and aggradation, which forms new habitats in the river. For example, gravel banks, driftwood, and so on. And the river banks
are also affected. There were steep banks, undercut, Merner, bluffs, and
so on. So floodings are important, for example, spawning fish and nesting birds. The sluice gate for the bypass river is constructed to bring permanently water to the floodplain and to initiate a natural side arm of about 8 kilometers of length. The gate works as a bypass to go around the hydropower station. Migration of fish and other animals is now possible again. The sluice gate can let out 5 cubic meters per second at maximum. The water is taken directly from the Danube. Mean discharge of the new floodplain river is between 2 and 3 cubic meters, depending on the discharge of the Danube. The effects of this new bypass river, named Ott-Heinrich-Bach, are next to the possibility of migration for fish. The river serves as a habitat for different faunistic species. The gravel banks created by the ecological floodings are spawning areas. Driftwood and shallow areas serve as a shelter for young fish and other species. Steep river banks and undercut meander bluffs are attracting kingfisher and bank swallow. The water of the bypass river is partly seeping into the groundwater, but brings also more moisture to the soils in the semi-aquatic areas. About the half of the bypass river, there is an additional connection to the Danube. It's an outlet to the Danube or an inlet from the Danube for migrating fish. And this additional connection is built after the bifurcation of the bypass river. At this point, about 15 cubic meters per second are flowing back to the Danube in case of ecological flooding. Under normal conditions, they are 1 or 1.5 cubic meters per second. The stretch before the mouth of the bypass river into the Danube is one of the most active parts regarding erosion. Furthermore, it is the best access for migrating fish because it's a strong and attractive current, and there are many gravel banks for spawning. The groundwater management in the east noticeable, and the groundwater level often is much too high. Therefore, mostly in late summer, the bypass river is blocked at 2 positions and a small sluice gate is opened right in the middle. All the water is now flowing via the additional connections, see before, back to the Danube, and no water can come into the system from the Danube because it is closed. This measure is draining the eastern area, and it is possible to draw down the groundwater to a certain extent. So did you see the video or not? I wasn't sure.
Yes, we saw most of the video. Yes, only in the final part. For some reason, we stopped seeing the video.
I think my voice was a bit before the video, so I was 2 or 3 seconds before, and maybe that it stopped during to this. So the sound was different to the video. I don't know why. Was it okay, or shall I start it again, or shall we?
No problem, Bernd, because we can also edit it to the final video, so there will be no problem. The viewers will be able to see it online.
Yes.
We do it like this.
This would be nice. So
Thank
my voice will be according to the video.
Yes, it will match. It will match. Thank you so much. Just to keep the timetable, I remind you that it's mostly 10 minutes per speaker, so as not to make it too long. And also, I would like to remind our viewers that if they have any questions for our speakers, they can put it in the Q&A box, not in the chat room, the Q&A box, to start a discussion after all the presentations. And now we can move on. Thank you again, Bernd. Thank you very much. We can move on to DPS 4. And Michal.
Hello, everybody. I am Michael Kravčík from Slovakia. and I am from NGO People and Water, and we make a lot of research 30 years after Velvet Revolution in Slovakia about water management, integration water management plan. We have some experience with communication with stakeholders and how to help to protect of landscape and to restore of landscape and increase to saturation of rainwater to the soil. And our demo site is about the restoration of dry springs and small creeks, because in historically last 60, 70 years in Slovakia was drastic influence on industry of agriculture, urban and forest management to stays of water and to very fast runoff away of rainwater to streams and to river, and the results is that we have is growing drastically fluctuation of flood and drought, and we need to solve this problem. And our demo site, Lighthouse, is about to find this interaction and relationship between landscape design and restore of influence of springs mostly, and to help it for streams and river to stabilization of hydrological regime. And we have, apart from these activities, sorry, it is possible to how is okay. This is typical how it was change of landscape structure in Slovakia before and now, and about this agricultural landscape, and just now it is completely different. And look about these forest areas, about droughts, and how is flowing rainwater from the landscape to the communities, and it is a really dangerous situation. And we need to solve this problem. Another problem is, sorry, I have problem to sharing of slides. I don't know why.
Michael, we're already sharing.
Yeah, okay. Another big, very extremely influence of the states of water on the nature and to degradation of drop of underground water and hydrological regime is sealing of earth, and looking about this reality and influence on the change of hydrological regime. Next slide, please. Yeah, and this is how is about to distribution of rain. We have problem about time and space change of distribution of rain, and slowly is growing in mountain areas and decreasing of in lowlands, in open, mostly agro-urban landscape and territory, like close to Danube, about soft west side of Slovakian, and to look about how is change of distribution of rain in a time. We have problem about drastically decreasing of precipitation in springtime, with increasing of heavy rain and with creation of heavy flash floods in summertime. And just now we are here in Slovakia, and a couple of minutes I will be talking Slovak TV about this reality, why it is about problem and what is necessary to do. Next slide, please. And we are starting couple with other activities to restore of landscape protection and to decreasing runoff away from the landscape. And first biggest project was in High Tatras National Park to restore of nature after windstorm, and helping to build a lot of check dams and natural-based solutions for harvest of rainwater to ecosystem, and to planting of trees, different kinds. And look about this after 15 years. It is very useful and good protection of nature, with completely decreasing of runoff rainwater from catchment areas, because all water is saturate to soil and support to springs and vapor to atmosphere and make cool effect. Next slide, please. And we, on the government level in Slovakia, was after historical floods, and was built a lot of water retention measures, which are bring quite good good reality for to invest money to landscape together with community participation and forester participation, agricultural farmer too, and NGOs group. And the idea is to how to building a lot of water retention measures, which will be keep rainwater on the land together with saturate to soil, increasing water balance on the in geological structure and help for springs, because his last couple of decades was in Slovakia was completely dry up of thousands and thousands springs in whole territory. This water retention measure was built around more than 100,000 in 1 year. It is very effective system how to harmonize the system, and we prepare this methodology how to be prepared this concept for implementation, not only in one region like in Kisuce, because we are in Vah River together with small part about 1,000 square kilometers in Kisuce. And the whole idea is to how to helping to restore all nature to decreasing of runoff and create better hydrological system in Slovakian rivers and the Danube River too. And next slide, please. And this is about couple solution and participation with people, and to create this cascade of different solutions, different quality and naive solution, nature-based solutions, from wood, from stone, from another water retention ponds and so on, which harvest rainwater to ecosystem and create good conditions for prevention to flood, together with support creation of water sources on the nature. Next one slide, please. Look, and this is our part of demo size project in Kisuce. Is one tributary to Vah River and one river, Vah River flow to Danube on the close to Hungarian, from opposite side from Hungarian side. And it is about 1 square kilometer of landscape, which is a lot of damage places. And the idea is to starting to thinking about the reality, about what is mean about one small spring and one small creek for better condition of water sources. And Slovakia is 96% from all Slovakia is runoff to Danube. It is catchment areas from Danube River. Next slide, please. Very fast. And we are established this monitoring system on the 10 locality, which is these localities micro catchment areas, which is about 50 to 100 hectares. And the idea is to make monitoring system. We just now analyze whole structure of landscape together, and we will be implement some water retention measures, nature-based solutions on the principle nature-based solutions, to rainwater harvesting, and on the monitoring system to decide what is impact, and after that to make calibration system, and to propose for another catchment areas in Slovakia, maybe in Romania, in Germany, Austria, and Slovenia, because we know about reality which was in last summertime about huge, very endangered flooding, which is results from time and space change of distribution of rain. Next slide, please. And this is benefit for potential stakeholders. It is about for to good condition for forest landscape, because it's produce more woods, produce more water. It is sequestration of carbon too. For agricultural lands, it is increase of fertilizing of soil, because with increasing of water balance on the ecosystem, it is good condition for increased photosynthesis, and photosynthesis harvest by photosynthesis harvest of CO2 to soil and create organic carbon, which is very important for fertilizing of soil and production of security of agriculture industry. Another problem is about how to create this prevention to flooding in agricultural land, to decreasing of dry up of lands, together with supporting of biodiversity. And the idea is to make results from preventing of drought and flood and support of biodiversity too, and cool effect from this. And benefit for water resources. We know that its idea is we just now have in theoretical calculation how much water retention necessary to build nature-based solutions, and what this means for example, for 1 liter per second of new water sources. And we will be confronted with theoretical knowledges with reality on the monitoring system, and we will be know, I think, from our research next year about first results, which will be quite useful for that. Next one, please. This lies its benefit for potential stakeholders, because it's, for example, it's protection of water sources and increasing of water sources, which has now run away to sea. It is water from small water cycle. Before that was this water saturate to soil, increase water balance, and helping for water sources, and vapor to atmosphere. And these water sources just now, after damage landscape, is run away. And we need to find this methodology how to make a landscape design for better condition to run rainwater harvesting to ecosystem, and what will be good for economy. It's for agriculture economy, for forest economy, for protection of nature, together with, and we need to implement this model on the urban zone. Is this big challenge, how to decide new challenge, because in history and after industrial revolution, we forgot that rainwater it is not a gift, but it is waste. This is a big problem for understanding, because a landscape planning process, we forgot for rainwater management system, and we need to decide it to quite good relevant information. And our goal and our dream is about to bring these knowledges to auditorium, to consortium. I think we will be many times we will be speak about that. Thank you for listening to me. And just now I am switch off to Slovak TV, and after that I return again to participate on the webinar. Thank you for listening.
Thank you very much, Michael. Very, very interesting. It's good to hear that you will be joining back, because I guess there will be questions from the audience. If you can't make it, maybe we can keep the questions addressed to you and reply and distribute them somehow to the audience, but I hope that you will be able to join us back. Thank you very, very much. Thank you. Now let's move on to DPS 5. Jose, will you be the one sharing? Yes, perfect, perfect. Thank you very much. So Attila is here. Welcome. Thank you for joining.
Thank you very much. Hello, everyone. My name is Attila Bezdan. I'm from the University of Novi Sad from the Department of Management. And today I would like to present activities within our pilot site, Begecka Jama, within the DALIA project. And first of all, I would like to thank the organizers for the opportunity to present activities in our pilot site. So next slide, please. Our pilot site is located in the north part of Serbia. It is located on the Danube River. It's actually a complex area. It consists of the protected nature park. In this detailed map, it's located in the lower part within this green dotted line. Most of the area is forest area, a wetland area. There is one large fluvial lake, which is connected with the Danube River. And the total size of this part is about 400 hectares. And there is a nearby drainage area, about 5,000 hectares. The drainage system consists of canal network and the pumping station, draining the excess water into the lake, which is connected with the Danube. And by draining the excess water, it also collects the pollution from the area. This area is under the intensive agricultural production. So there are chemicals from agriculture present, like fertilizers, pesticides, etc. Then there is a large illegal dump site area, polluting the area. Then there are 3 villages discharging wastewater into the canal network. Actually, the problem in this area is complex, and one type of problems is regarding the hydrology. But I won't talk about that today. I will focus on the pollution coming from the drainage area into the protected nature park. Next slide, please. So a little bit about the Begecka Jama Nature Park. It is actually a floodplain. It has several geomorphological forms of erosion, like island, bridges, oxbows, backwaters. It has a large fluvial lake. You can see some photos from the area below. So next slide, please. This protected area is very important for the flora and fauna. There are about 125 species of plants, about 150 species of birds, many species of fish, amphibians, reptiles, insects, and many of them are of national or international importance. And actually, we are trying to protect this or save this from the pollution. Next slide, please. So, as I was mentioned, we are focusing here on the problem regarding the pollution from the drainage system. So there are illegal dump sites polluting the area, chemicals from the agriculture, and wastewater from 3 villages discharging into the canal network. Please, next slide. So what we want to promote here is a constructed wetland system. This is a facility for treating the wastewater from one village. That village is called the Gložan, and this is what we would like to promote here. Constructed wetlands could be classified as nature-based solution because they utilize natural vegetation, soils, and microbes for treating the wastewater. They are, of course, artificial wetlands that are used for treating organic, inorganic, and excess nutrient contaminants in wastewater. They are engineered system that use the natural function of vegetation, soil, and microorganisms to provide secondary treatment to wastewater. And actually, it is a very common technology, and these kind of systems are applied in many parts of the world. Please, next slide. So our system, it was built about 20 years ago. It is operational since 2004, and our institution was involved in the designing of this system, and of course we are involved in monitoring of the effects of the wastewater treatment. There are many types of, or actually few types of constructed wetland system, and this has a horizontal subsurface flow type. This type was selected to, let's say, to prevent bad odors in the air, because this system is located very to the village. A little bit about design. On the lower, at the bottom, there is an impermeable layer of clay. Then there is a layer of gravel with different sizes, and upper layer is a mixture of gravel, soil, and vegetation. And in this case, vegetation used as a phytofilter is common reed, which could be found anywhere in this area. This system consists of three cells, and wastewater flowing through this system for about 5 days until it enters the canal network. And the total area of this system is almost 1 hectare. Please, next slide. And some information regarding the efficiency, some information from the monitoring of efficiency of treating the wastewater. For example, the suspended solids are removed in efficiency of about 95 to 80%. The efficiency of removing the organic matter, which is a biochemical oxygen demand, is about 85 to 80%. Then efficiency of removing nitrogen compounds is about 5 to 45%. The removing of phosphorus is a little bit lower, about 40 to 25%. And of course, the treated water which enters the canal network is considered to be microbiologically safe. So next slide, please. And in this slide, I would like to summarize what I have presented. So these kind of systems are suitable for small loads of wastewater. So they are convenient for small settlements. This was designed for about 2,000 people. And this is a clean type of technology. There are no negative effects on ecosystem or landscape. They cost less than conventional systems, and they have a lower operational and maintenance cost than conventional systems. But on the other hand, they demand large areas. They're regarding the consistency of the efficiency of treatment. They are a little bit less efficient than conventional system, and they have some limits regarding the complex treatment of complex pollutants. And the literature suggests that the operation of actually the lifetime of this kind of system is about 15 to 20 years. Our system is working for 20 years now, and our monitoring showed that we noticed a little bit of decrease of efficiency, but still we considered that it is very efficient for treating wastewater from that particular village. So basically, from what I presented, we believe that these kind of systems are very suitable and that would have good potential for being replicated in associated regions. So my presentation was much shorter than previous. So thank you very much. If you have any questions, I'm here to answer.
Thank you very much, Attila. That was very interesting. Thank you very much. And now we can move on to DPS 7. The first presentation will be a video presentation because the speaker could not be here with us due to holiday in Romania. So we will carefully watch her video and then we will continue with Stefan, again on DPS 7. Jose, you must be having the presentation to share.
Yes, 1 minute.
Yes, sure, no worries. And once you're taking your time to upload to share the presentation, let me remind to the audience that if you have any questions, you can put it in the Q&A box. That's different than the chat. They're next to each other. One is the chat, one is the Q&A box. Please use the Q&A box for your questions. So I can.
Hello, my name is Maria Cristina Trifu from National Institute of Hydrology and Water Management from Bucharest, and together with my colleague from University Dunărea de Jos of Galați, Mr. Ștefan Petra, we will present you the pilot area number 7 concerning Danube Delta, especially Sulina branch. The partners involved for this study area are National Institute of Hydrology and Water Management from Bucharest, which is a national authority of hydrogeology in the water management, and the Romanian Waters from Bucharest, and the Dunărea de Jos University of Galați, which will be involved in this project through the RexDan research infrastructure, which has performance research equipment of new generation. Together, we'll present you details about our pilot area.
Objectives: improvement of monitoring system and knowledge of sediment flow spilled in the Black Sea, monitoring the amount of suspended sediments transited in the Sulina Canal, and knowledge improvement of the sediment load, monitoring the pollution of sediments and biota by developing different models. Sulina branch, 71.7 kilometers long and extended by another 8 kilometers into the sea, located in a central part of the Danube Delta, is a navigable branch as a result of numerous rectifications and dredging works. The Sulina Canal is the shortest branch of the Danube Delta. In order to maintain its navigability, a 10 kilometers long dike was built, removing the alluvium brought by the circular current of the sea, and continuous dredging of the arm is necessary to keep it navigable for marine ships. Since the branch is an important navigation channel, increased shipping traffic affects the water and sediment quality. A continuous process of erosional sand deposition occurs due to changes in water currents. All the polluting substances brought to Sulina city from the upstream area are due both to the discharges of polluting materials as well as to the use of ships and boats, representing the only means of transportation in the area, or to the transit of marine ships. The contaminant transport out of the catchment area into the marine system is of particular importance when dealing with sediments. The Sulina branch is hydrologically monitored by 4 main hydrometric stations located at Ceatal Sfântu Gheorghe, Crișan, Sulina Port, and Sulina Semnal Ceață. For the mouth of the Sulina branch, the evolution of the mean annual discharge has a decreased tendency. Variation of the liquid contribution of the Danube River to the Black Sea through the Sulina branch were analyzed at annual level. In this context, for the period 1991-2022, the Danube's contribution to the Black Sea is almost 85%, while 15% remain into the Danube Delta. From the entrance on the Sulina branch to the final exit in the sea, the sediment load is constantly deposited from year to year. In general, since the 1990s, the variability of sediment discharges has been decreasing on the Sulina branch, with annual averages values below 200 kilograms per second. The National Institute of Hydrology and Water Management and the University Dunărea de Jos from Galați have proposed a solution to improve the monitoring system of the sediments that reach the Black Sea, thus ensuring a better knowledge of the quantity and quality of the sediments transported by the Danube River through the Sulina branch. In order to understand better the transport of sediments to the Black Sea, our researchers made new measurements of the water discharges and scanned the bottom of the riverbed with specialized equipment. After the hydrological measurement campaign on the Sulina branch, the activity has continued by processing the water and sediment samples. Our institute has a setup space with the necessary specialized equipment, where there were analyzed the water samples taken from different depth horizons from several sections of interest, and the samples of dried alluvium, and those from the riverbed collected in labeled bags. Thus, the water samples taken from 14 measurement sections were filtered in order to find out the water turbidity and to determine the sediment balance, this activity significantly contributing to improving the knowledge of the transport regime and their erosion and deposit phenomena. Currently, daily suspended sediment concentrations are measured one a day near the bank at the Sulina Semnalceață gauging station. In DPS-7, the National Institute of Hydrology and Water Management has proposed a solution to improve the monitoring of the temporal variability of suspended sediment load by using a continuous monitoring equipment. Concerning the sediment monitoring near the mouth of the Danube into the Black Sea, in 2023 an optical sensor was installed near the bank that will continuously record the turbidity at one point in the cross-section. The automated station will allow a permanent monitoring of the sediments, because the phenomenon of their deposition can cause serious navigation problems in the area. The automated monitoring station is equipped with 5 sensors: air temperature sensor with cable and solar protection, radar level sensor for water temperature, sensor for turbidity, and sensor for salinity. The automated station has also photovoltaic panel and data logger. Concerning the improvement of the monitoring system for sediment quantity, the innovative elements of DPS-7 is the dynamic control of sediment transport using continuous monitoring system together with water level, salinity, water temperature, and air temperature. We will aim to replicate in the other geographical area both the installation of the proposed continuous monitoring system and a developed technology for the improvement of monitoring system and knowledge of the sediment load.
Now, my colleague from University Dunărea de Jos from Galați, Mr. Ștefan Petrea, will present you the solution proposed for the improvement of the monitoring system for sediment quality.
Big thanks to Christina remotely then, who joined through video, and now she already made an introduction, Stefan.
Yeah. Thank you all.
You are next.
Yep. So thank you all for having me here today. Thank you, Anastasia. So shall I share the slide or?
Jose has your slides. Let me see if he will be able to share. Let's wait a little bit.
So until Jose will be able, I will make a short. Oh, now it's good. Yeah, it's perfect. So firstly, I want to say that our university, together with the a second partner from this demo site, had done some field measurements and target to use them in order to create some decision assistant tools for improving the monitoring within the region. So we all know that monitoring is quite cost demanding, and especially if you'll do it on a multi-layer, like in the sediment or in water, because they are all correlated. And we are trying, firstly, through our solution, to build capacity among stakeholders, because we are quite aware that stakeholders do not have the knowledge nor the capacity in order to perform in-depth analysis within some areas. And also we are trying to improve the sustainability, economic sustainability of this activity, because practically we want to ensure this activity as frequent as possible in order to be performed, in order to have data and to make forecastings and predictions. But of course, we want in the same time to be economic sustainable. So for the first, all the works that were done from our university, on behalf of our university, were done through the Riksdag Research Center, which is a center which resulted after very significant investment of the European Union with something like 19 million euros. So the center has a fixed and a mobile research part. The mobile research part, you can see it in the slide, is the vessel, which is the biggest one from the interior water in Europe, at 44-meter long. And on the lower part, you can see also a part of our young researchers who are into the activity in the field. So next slide, please, Jose. So within this slide, I've tried to structure the presentation so that I will describe some of the activities that were done within the demo site. And after that, to reveal what we can replicate, because this is the target of our meeting today, no? So our demo site, as my colleague presented, this Sulina branch, the center branch within the Danube Delta that makes the relation, the interlink between Danube and the Black Sea. So we've tried, and you see this in the left upper corner, we tried to to divide this branch into some sectors. So we started from Partizan village to Sulina city. We have there a number of 6 sectors. Each sector was analyzed. Firstly, the analyses were targeting the quantitative part, and after that the qualitative part, because practically you'll see later on my presentation that sediments are in a very strong correlation with water and with pollution, and we don't need to lose nothing related to biodiversity and so on. So that's why we need to perform this monitoring quite well and quite often. So some of the parameters that were monitored were the particle count per water column. So we number the particles of sediments. So also we make sediment concentration analysis per water column, and we will see the evolution from the upper into the downer part in the graphs from the downer part of the slide. And also we measure the sediment grain radius because we pretty much want to identify the flow of sediments through this branch and their dynamics. And also, as you see in the right part of the down corner of this slide, we have the profile for sediments in terms of sediments concentration and grain radius. The profile which was done in a certain period of time that permit us to do a kinetics, and after that by using some artificial intelligence tools to make forecastings. And also you can see in the same slide that we have also the flows. All these parameters will be somehow integrated in together with the qualitative parameters in our analytical framework. So in next slide, Jose, if you please. You will see our qualitative parameters. So these parameters were associated also to water and to sediments, because as I said before, they are quite interconnected. So practically the sediments transported by the Danube reach finally to the Danube Delta, and therefore to Sulina branch, which is one of the 3 branches. So those sediments bring a lot of pollutants, since the water from the Danube crosses a lot of countries area, which are quite industrialized and focused on blue economy. So practically, we've tried to monitor some of the parameters which we consider important, like heavy metals or nutrients, or other parameters like pH, temperature, dissolved oxygen, chemical oxygen demand, or biological oxygen demand. Yeah, so practically all these nutrients were monitored in order to establish correlations between the sediments and the water in terms of quality, and to be integrated further on together with the parameters from the quantitative part in a very holistic analytical framework which can explain us many of the variation, and at the end can show us some soft sensors or some virtual sensors, which are some sensors that can be used based on mathematical models in order to determine those parameters at the end without any spendings. So our solution will be quite cost effectiveness and will ensure the integration into a bigger platform in order to create these ecological corridors that Horizon Project are targeting to do it. So next slide, please. Some words related to our framework and the way that we do this. So we are generally using machine learning and deep learning algorithm. In the deep learning part, we are using neural networks, and also we are using forecasting models if we have time series analysis. And as you saw from our presentation, we have some data related to time series. So practically the data, all those data that we are gathering from this area, we are we are doing a data cleaning to them, and after that we are making some statistical correlation and analysis, and we are developing a lot of prediction models which are targeting to determine a dependent variable, which will be our virtual sensor, by analyzing some predictors which will be the parameters which are very low in terms of cost demanding, and which are also very permitted in terms of knowledge in order to be monitored. So practically our solution proposed that the stakeholders could analyze some parameters, basic ones, and based on that parameters that can insert the parameters into our equations and identify the values of some more, let's say, exotical parameters like heavy metals. And so practically we are doing virtual sensors for making the monitoring more easily. Also, the time series models give us the possibility to know what will happen in the future. So these forecasting models gives valuable information to stakeholders in order to adapt and to plan their actions based on some data. And those data are these forecastings, which are quite accurate for now, but will be maybe more accurate in the future. So practically our solution is an open solution that will be upgraded each time when some analysis from some academia or university or the members of this quadruple helix that we are targeting will give some upwards of the data. So next slide, please. And so practically what we can replicate our models and our analytical frameworks and all of those forecasting models that we use. We can replicate it if we have historical data. So practically the persons which are interested to replicate this into their replication sites must think about the availability of the historical data within that area, because we will use the data in order to train our algorithms, 70% of the data and 30% in order to validate our algorithms and to optimize them for their replication sites. What they will gain an analytical framework that will give them some data related to some parameters which are very hard to be determined, which you need equipments in order to determine them. You need in situ campaigns. So practically they will be able to monitor all of this without effort or with minimum effort. So practically we will build capacity among the stakeholders and the communities of practices that are formed or will be formed within the replication sites. And also we have also a long-term milestone, because practically our solution is an open solution that can be integrated within other platforms of within the project platform. So practically within based on this solution, we can create synergies, and also we can establish green ecological corridors, especially within the eastern part of Europe. So next slide, I guess, is the thank you slides. Thank you for your attention, and hope I transmitted the information as clear as possible, although there are some technical aspects that you know, maybe they will need further on discussions at the end of the meeting. Thank you. The mic is yours.
Thank you very much, Stefan, for the presentation. We have a question. I think this is addressed for you, but I guess it's better to address it at the end after DPS 8 to avoid any delays. So we thank you very, very much again. And now we go to DPS 8 and Miklos. The stage is yours. Thank you for being here.
Thank you very much. Welcome to all. I'm Miklos Gyarai Korpos from Plastic Cup Society and representing here the Bodrog River pilot site in the DALIA project. Next slide, please. So the Bodrog River is basically in eastern Hungary and Slovakia. It's an interesting river because it has no source. It's called Bodrog from the joining of two rivers in Slovakia. And our pilot location is the Hungarian section, which you can see with yellow in the map. Actually, it is like 50 kilometers long. And as you can see, some of the rivers there come from Ukraine, from Transcarpathia, and the end of the Bodrog River is at the Tisza River at Tokaj. You may have heard about the Tokaj wine, so this area has really a lot of natural, historical, and culinary values. But of course, it has some challenges. Next slide, please. So you may have already asked, why do we need to save this river? Because actually, if you would take a walk in the floodplain, you easily can run into this site, which is not really nice. It's rather ugly. And the reason for that on the upstream of the river, mainly in Ukraine, in Transcarpathia, it's a regular practice to dump the household waste into the floodplain, and the flood picks that up and spread downstream. It's not that typical for this Bodrog River, but also the Tisza River, and probably also other rivers all around the globe. So this also shows that the plastic pollution issue is not just something in the developing world, but that also impacts Europe and the rivers here. So next slide, please. And what have we doing against the plastic flood? This is how we call it. We established the Plastic Cup as an initiative like more than 10 years ago, which now is a river cleanup protocol and also a registered trademark. So it's a protected trademark, and now we have been becoming international. DALIA is just one of our international projects, but we think it's really a great opportunity. But we also participate in other international projects and also have successfully carried out cleanup and educational activities already beyond Hungary. And this is the reason that we are one of the most influential and effective river cleanup initiatives in the Danube River Basin. And we believe really in sharing our know-how and experiences that we have gathered in the more than 10 years. And as you can see on the picture, we have 3 legs. One of them is cleanups, organizing cleanup sections and sharing the knowledge about cleanup. The second one is education and communication, because we also really think that avoiding the waste coming into the river and avoiding the production of waste is really important. And the third leg is research. We have been carrying out a lot of research activities to learn better the plastic pollution. And as a result of our more than 10 years, we collected like 300 tons of riverine litter, and we also have a sorting protocol. So we basically sort what we get out from the river and we recycle what we can. So we can recycle the PET bottles, the metal, the glass. So it's like 2/3 of that actually is value that can be recycled. And with educational and other actions, we prevented and diverted like 700 tons of waste coming to the river. Next slide, please. So, and what we are aiming to do within the DALIA project on the Bodrog River to fight the plastic pollution, we align the activities according to our 3 legs. So in the research area, we further develop our river saver mapping, because it's really important to understand where in the floodplain area we face the trapping issue, where we have the plastic pollution deposits. we have developed and we would like to further develop and apply our GPS bottle, which is, as you can see on the picture, is a normal bottle with some technology inside, allowing us to follow real time the route of the bottle. And we started to experiment with remote sensing to see where the waste is from the aerial photos. As you can see, also an example for that. So we are going to further develop and apply those research fields within the DALIA project. Next slide, please. Regarding cleanup actions, we are going to organize cleanup actions along the Bodrog River. Actually, our first winter cleanup activity will be organized just like within 1 month. And also, it's very important that we involve local stakeholders because we want to teach them, to educate them, to feel responsible for the river. And we develop a methodology and protocol for organizing cleanup events. And we also work with boats and other technological solutions, which we call professional cleanup. So this is also a technology development direction that we are going to develop here and test on the Bodrog River. Next slide, please. And the third leg is environmental education. We have also large experience in this. On the picture of the bottom, you can see our traveling river litter lab that is on a trailer basically, and we can go to a school or to some events by that. And within this trailer, the pupils can learn how to recycle plastic. Actually, they can grind the plastic. They can create a different object from plastic with injection and so on. So this is what we want to carry out also in the Bodrog Valley to reach out to schools and pupils. And we are working on different protocols. We call them river saver protocols. This is, for example, how a school can adopt a river shore and take care of the river shore, which is like a key for keeping the river shore clean for a long time. And also we are developing a river saver center at the river, which is to say the headquarters for cleanup and can be also a place for educational activities and so on. This is something we want to show for the DALIA partners also in the project meeting we will host in the future. Next slide, please. Okay. And you may ask, okay, but we can replicate that. We always work on protocols and know that we can transfer. So we are working on to say a map, a portal where you can learn and download all these protocols and guides, and where you can also map the pollution spots on the river nearby you. This is just a snapshot. This map is under development, and soon it will be public. So you can with the use of an application, you can also help us by mapping your polluted areas, also organize cleanup based on our know-how. And also, if you want or you know a school, for example, and want to take care of a river shore nearby, you just adopt the shore by using the protocol and then be part of the network of the river saver schools and so on. This is also thanks to the DALIA project under preparation, and more information will be available. So really, thank you for your attention. This was my last slide, and happy to have questions.
Thank you, Miklos, very much for the presentation. Miklos also has a very interesting video about the activities in Bodrog River.
If we can play that, that would be nice, but I know that we are beyond the agenda, so it's really up to you. I would appreciate it.
Maybe at the end, if there is some time left after the discussion and you can share. Otherwise, we could possibly include it in the comment section of the YouTube channel, or even in the description for people to visit. It's a very nice video, guys. I suggest you see it. So thank you very, very much. And let's move on to the Q&A. Okay, the first one was from Nade Zidja. I'm killing the names today, guys. I'm sorry. Okay, so the question is, thank you very much for the presentation. I have one question. How an ecological expertise is harmonizing with water management on each levels, EU, regional, and national? So I'm guessing with this question, I'm not sure exactly who you were addressing in the panel. If you can specify, it would be perfect. If you're addressing it to a specific person, I understand that somehow you mean that with the activities within demo sites, somehow we need to combine EU requirements, regional requirements, and national requirements, if I understand the question correctly. And if I could answer and then pass on the microphone to the speakers, I would also stress out that as DPS 1 and 2 mentioned, it's very important to include stakeholders in each step of the process, just to make sure that all interests are covered in all cases, because you have ecological footprints, but you also have human activity, which needs to be balanced. We cannot stop the flow of the rivers, let's say, just because of human activity. And we can say that if we go with the flow of nature, we can also have benefits for ourselves too, as we saw some examples in tourism. And of course, there are requirements from the EU. And I guess that one of the goals of this project through all these monitoring processes is to see how we're standing and whether some of those measures could be readjusted, maybe as proposals to the policymakers. I don't know if I have answered your question, or if any of the speakers would like to say something about it. No? No hands? Okay, then I will consider this question answered. Of course, we can always have a discussion in the comments section after the video is posted online. So I will encourage you there to start a conversation as well. It would be very interesting. And now I will move on to the next question. I'm guessing that this has to do with DPS 7 because it was posted at that time. To what extent, Stefan, I guess you are entitled to address this. To what extent are you integrating with ongoing EU projects in the Black Sea Connect, Bridge, BS, to understand the role of freshwater management in coastal restoration and marine NBS activities?
So, yep, if it's addressed to demo site 7, the idea is that, of course, we have to interlink the Danube with the Black Sea. So practically, the Danube Delta is the missing part within this microsystem, which must be quite well known because all the sediments and all of the pollens are coming to this part of Danube Delta, and after that go to the Black Sea. And we have to do a synergic approach to them. So we are developing these analytical frameworks based on some sensors and also forecasting models. And we try to link it to the already existing platforms. So if there are free platforms like the ones developed in the project of Black Sea Connect or Black Sea Bridge project, we can speak with the representatives that are dealing with that platform in order to connect to them and to make a data sharing, because practically we will have the data and we can deploy the data within a very big API in order to create these holistical approaches. So practically we have to work interconnectedly, but firstly we have to have clear data within the project. We firstly are within the testing periods. So we have some data, we, let's say, run some models, but they are not the final models. When we will have something final, we will propose to the already existing project a cooperation within this synergy of sharing the data, deploying data to their platform, or them deploying data within our platform. And after that, of course, having the data from the Black Sea, having them from the Danube, they will interconnect each other and give us some correlation. It's clear about, yeah.
Thank you very much, Stefan. And this, I see here an opportunity, because indeed, there's another question. I can correlate the two. Are you preparing joint meetings with other projects from the Danube Basin in order to exchange information and innovations? And yes, indeed, we have reached out to some projects, mostly in the communication part, but since there is a very huge correlation in these activities, we can always have one-to-one meetings. Feel free to reach out to me or to the coordinator of the project to arrange something together. Another nice opportunity to talk in person would be the clustering meeting, if you can join on the 19th of March in Brussels. The invitation will be open to you. And of course, if you have access to other initiatives and projects that are related and that can fall within the DALIA activities, and you find it interesting to communicate, or regarding the open call, of course, feel free to contact. We will be more than happy to have a discussion and see how we can correlate our activities. Jose, you raised your hand.
Yes, I have several questions that I received on my WhatsApp, but before, I'd like to comment on your response. It's important to also to inform that there is a CSA, a coordinated or supporting action for the Danube, which is called EcoDALI. And they are trying to put together all these projects to meet once in a while. So I expect Nadia, she's the coordinator, will do very quickly. And then if you leave your contacts to Anastasia, I'm sure she will include you on these meetings in the Danube Basin. I mean, yes. I know that they have to do it because I'm doing the same for the Atlantic and Arctic. Yes.
Yes. The EcoDALI is the CSA for the Danube, of course. So each connection that you might send me, I can also forward it to EcoDALI with the opportunity of the talk we have today. The EcoDALI is also organizing the Danube newsletter. It's about every 2 or 3 months, depending on the content that each project is creating. So if you visit their website, you can also join their newsletter and stay in contact with EcoDALI. And I think that the activities within EcoDALI and the clustering events that will be organized in cooperation with the BioEast initiative and the thematic working group on freshwater management will be a nice opportunity to see each other and discuss in person, apart from meetings that we might be having online. So yes, thank you, Jose. Very, very nice. Thank you for pointing it out.
Yeah. So if I may, I have here basically one question for each one of the speakers that I received from YouTube. They send me by WhatsApp. This is normal procedure. First, Jerry Miller sent me a message congratulating you for this very interesting collection of projects. Jerry Miller is from the US. He has a consulting company. He was very much impressed with this. Thank you, Jerry, for sending me this interesting message. And first, a question for the first case study is, let me see here, but they wrote, yes, it's to Matej Chapon. They asked if these solutions that we installed, like this dynamic flood control, they need constant maintenance, they need, any kind of human intervention a long time, or once you install them, they are there forever. Forever, I mean, it's too long, but at least how long do you stay there, not needing constant human intervention?
Yeah, okay, thank you very much for the question. And the answer is that this is an operated system. So there are operating personnel, there are sluice gates included in the system in case, or in fact, many of them to control the water levels according to all the stakeholders, which actually include, so the stakeholder is in the area include environmental protection as well, and they have their demands for water replenishment and water levels. So this is an operated system, and about the replication, we would suggest that if there is a system that is already constructed, it could take advantage of our expertise of operating the system differently and maybe including more demands from stakeholders, and to have a better outcome for the environment as well.
Thank you for your response. I mean, I know there's one for Bernd. I mean, it wasn't clear for the person who sent me the message. What is the real replication possibilities of your solution? Meaning, can it be replicated in, let's say, I mean, icy areas from the Arctic, where I am now, I'm in Oulu, Finland, or other areas, Mediterranean, or your solution is specific to the region that you developed? The technology and the science for that.
Yes, thanks for the question. Our solution is a bit specific, but for climatic regions where we have flowing water. So Arctic and maybe Mediterranean with the non-permanent rivers, it is maybe a bit difficult. But if you have a river, no matter what size, and you have the necessity that you have a drying out floodplain, maybe by levees or by whatsoever, you can use this solution to let out the water and to guide the water maybe in old meanders onto the floodplain and also back for a fish passage if you have a hydropower station. But it's not necessary to have a hydropower station. If you have the need to bring more water to the floodplain, we can take this solution and scale it down to smaller rivers or whatsoever, because the Danube is a very large river. Not really in our area, but if you go downstream, it gets larger and larger. But if you have rivers with an average discharge, let me say 200 or 100 cubic meters per second, you can use it also.
Yeah, thank you. So it means that you need some, water dynamics to implement your solution. No, a minimum amount of flowing waters. Yeah.
The solution is designed to bring back dynamics onto the floodplain. And for these dynamics, you need water to play with. That's not to play. In former times, nature played with the water, brings up floods and brings up dry season and so on. And now it's artificial. I have to admit that we are faking nature with these solutions, but sometimes it's necessary to do this.
Yeah.
Because man has did so much harm to the nature that we are forced to do this way.
Before the next question, let me go back to this fake nature, because I already participated in several meetings that say something similar. So, what would be for you, why fake nature? Because you couldn't restore to the original state, you still need human interventions. Why you categorize this, as many others, as fake nature?
Let me say, I was on a conference in the USA, in the United States, and I showed them the entire setting with the Danube and the side river, the tributary, the Lek River, and the Lek River has 29 hydropower dams and maybe 12 or 15 at the Danube. And I told them, yes, we are controlling the flood water that we are bringing onto the floodplain. And one guy was telling me, you are controlling the controlled. And that's why we are faking a bit the nature. If you have no controls on it, like in the Danube Nature Park in Austria, in Vienna, they did nearly the same, but without control. They have concrete levees, and if it spills over these levees, it's nature. And we are waiting for a certain extent, 600 cubic meters per second, and then we can let out the water onto the floodplain. And so this is the controlling, and this is a bit the faking. Otherwise, nature would take the flood, the water would come by itself on the floodplain.
Well, thank you very much. Very interesting observation. And I have a question for Attila. I mean, in your presentation, you said that, I mean, the efficiency of the area, I mean, let's say going down and down. What are the plans for the future? Will you have to create a different area? You have to, let's say, restore this area. And if you move to another area, what we're going to do with this existing site?
Well, thank you for the question. Well, the existing site is actually, the performance is a little bit lower, but is still considered as efficient. And actually we are planning to extend this, because there is a place just beside of existing constructed wetland. There is a place for another one to be able to receive more wastewater loads from this village. And of course, it's on how to say, improve the maintenance, because there were case of lots of clogging of pipes and hydraulic structures with the with the mud and with the grease. So the maintenance should be a little bit improved, and to the monitoring also, the sludge in that cells could be more improved, and when the sludge is at a high level, it should be removed from those areas. So this is for our current site. Of course, similar ideas could be applied in any other constructed.
Sorry. Okay, thank you so much. I mean, we still have time for a few more questions. Sorry, Anastasia, because I've received all these emails, all these messages, so I keep asking here. This one is for Mikkel. I mean, this is a very common question that you get. You know, we have a lot of participants from Africa, South America, and the question is, your monitoring systems to assess the impact of landscape is open source and open hardware? And if it is, how they can know more about the technical details that they can replicate?
Yeah, it is question for me, or?
No, yes, for you, Mikkel, yes.
Yeah. And it's main goal and reason why we implemented this monitoring system is to analyze with the relation between landscape structure and damage of landscape on the hydrological regime in the top part of landscape and catchment areas. And after that, to make some calibration system and to propose, for example, what is necessary to do on the 1 hectare of forest land for increasing of water retention capacity due to damaged landscape. It is one. The same for the agricultural land, and another is about these urban zones. And this is, I think, it is extremely important, because with water which are before, for example, couple decades before, was infiltrate to soil and vapor to atmosphere, and was connected to small water cycle, and with water loss from the system. And after that, if it's after damage of landscape and with water which are runoff away, it is lost from small water cycles. And I am sure that it is contribution to sea level rise. And in Slovakia, 20 years ago, we analyzed about this hydrology, how it's changed. And we decided that it's annually lost from Slovakia 250 million cubic meter of rainwater, which are runoff on the surface and flow to Danube River, create increase of flooding situation, and bring this water with sedimentation to sea. And idea is to how to manage of landscape and create condition for better saturation, increasing of balance of water underground, and to increase of condition of and vitality, not only for water sources, but for biodiversity, fertilizing of soil, and thermoregulation of the system and biodiversity. And I think with this connection between DALIA project and connection and interaction to sea, like not only to Black Sea, but Atlantic Sea, I think it's necessary to really open this debate on the research authority, how we have impact on the desertification process and loss of water from the small water cycles, because it's one reason why it's just now is massive flow, it's huge raining in Europe. It is results about thermoregulation, because its biotic pump is starting after October, dramatically decreasing of dry lands, and from this side is starting from Atlantic, pumping from atmosphere a lot of water to the system. It is danger too, because it is problem about this desertification and growing of extremality of heavy rain and flash floods. It is really, we need to solve this problem of the academic level too.
No, thank you so much. Yeah, good response. Very interesting. All the responses were very interesting. We have two, at least on my side, two final questions. One, again, very common, is to receive over here. I mean, this is for Stefan. I mean, in your replication potential, you write that, I mean, you need site data, historical data related to water and sediments. How can countries, emerging economies that do not have much data on that, I mean, build on your solutions and try to replicate in other areas, not only in Europe?
So so practically, if you're using artificial intelligence and machine learning, you have to have something which is real, because practically you cannot develop virtual worlds of sensors without any surveillance, in situ surveillance. But our solution is like this: we already done the framework for our virtual sensors, and the entire analytical framework will be also more developed within the project. So the only thing that we can offer is to have a limited number of historical data in order not to demand more from these countries, because practically the model should be optimized with the in situ solutions. So it's clear that each ecosystem is peculiar. They are not ecosystems similar. And practically our model will be developed for our ecosystem. If we find the ecosystem which has some common peculiarity to ours, we can go with the model there and adjust it and optimize it with some previous data. If we don't have any data, we can implement there some monitoring solution which are cheaper, because practically at the beginning I said that we are using predictors from the part of the parameters which are quite cheap to be determined, like pH, oxygen, turbidity, and so on. So practically these analyses do not demand high input, financially speaking. And therefore our model can be more affordable. But of course, you cannot replicate something without investing. That's why within the call, we have a replication budget for the replication sites. So the replication budget can be used in our case in order to create databases if we don't have databases for that replication site. And after that, by creating the databases, we can take the data and then train them and optimize our models. So practically, I don't see that the boundary here is related to the lack of financial, let's say, sustainability, because the European Union gives money to the replication site. So practically, we can use money to create our own data there. Yeah. Thank you, Jose.
Well, thank you so much. I had one more question for Miklos, but I know that he left. But I mean, I'll contact him. The question is just you to know. I mean, there are so many dashboards and mapping tools. And the question was if you are working together with the other mapping tools, like, for example, the IMDUS, the International Mapping of Marine Debris, or other, I mean, mapping tools of plastics, in terms of integrating your data and provide some insight on how we can link these, I mean, marine and coastal data to land-based data. That was the question, but I will send to Miklos by email. Of course, I will copy you, Anastasia.
Yes, by email, or I don't know if we can put it in the YouTube discussion, if it's open for comments, and maybe forward it to Miklos. He can reply directly there for the public to see.
Yeah. So, I mean, on my side, I mean, we are 4 minutes after time. It was a very interesting session, very, very interesting. So, Anastasia, if you want to close, maybe ask for a round, I mean, of comments. The floor is yours.
Thank you very much. Thank you very much for the hospitality and for the invitation. I hope that the speakers and the public enjoyed it as well. I hope so. And as for the last comment, I know that there are many channels, many projects, many, databases. It would be very nice to integrate. I know it's a lot of information, but there's always room for discussion. So it's good that we have the opportunity to share what we're doing and for other people to reach out to us. Again, thank you very much for participating. Thank you very much for providing your questions and your comments. I can see that there's a real interest, because I'm guessing that behind the interest, there's a real need for solutions. So thank you very much. And I hope that I can see you in the clustering event. More information will be shared soon. Also, keep an eye for the open call, because it will be on April. So this will also be shared with everyone. And I hope that we can leave a window of discussion open there. I don't know if there are any more comments, goodbyes, thank you, messages from the speakers to the public. Please take the floor. Mikael is waving goodbye.
Okay. Thank you so much.
For your patience. It was a 2-hour session, and I hope that everyone had a good time.
Definitely. It was a very interesting session. Okay. Bye.
Everyone for the organization.
Bye. Thank you. Bye.